Edward Grefenstette is a Franco-American computer scientist who currently serves as the head of machine learning at Coecke. He's also an honorary professor at UCL. He's previously been a research scientist at Facebook AI Research and a staff research scientist at DeepMind. He was also the CTO of Dark Blue Labs, a company which he co-founded. Now, prior to his move to industry, Ed was a Fulford Junior Research Fellow at Summerfield College, University of Oxford, and was also lecturing at Hertford College. He obtained his BSc in Physics and Philosophy from the University of Sheffield and did graduate work in the philosophy departments at the University of St Andrews. His research draws on topics and methods from machine learning, computational linguistics, and quantum information theory, and he's done work implementing and evaluating compositional vector-based models of natural language semantics and empirical semantic knowledge discovery. I really hope you enjoyed this conversation with Ed. It was absolutely brilliant. Enjoy. Ed, lovely to meet you.
Tim, likewise, a pleasure.
What are you all about?
What am I? It's such a broad opening question. I'm all about getting computers to understand and express language increasingly in line with human abilities. But more broadly, I'm interested in how do we get computer systems to be intelligent like us and serve humanity by eventually forming a symbiotic relationship with us rather than replacing us, which is the general fear people have.
Awesome. And in terms of papers and things that you're reading, what's top of mind for you?
It's always a great question. So one of the great luxuries I have, and perhaps great faults I have, is that I no longer have as much time as I used to as a graduate student or even as a research scientist at DeepMind to read papers. So the main way in which papers are bubbled up through my attention or the content thereof is bubbled up to my attention is through the students I have at University College London and through colleagues here at Coecke. Eventually, papers are important enough that I have to read them directly. So one of the ones I've been poring over lately is, I've forgotten the title, it's the latest paper by Anthropic. I'm very interested in some of their preference-based sort of like objectives, and I think that there's a lot of novelty to that sort of paradigm to go towards a more cognitively lightweight approach to getting feedback from users, and where all the complexity is more on the design end, which I find intellectually stimulating, but also makes a lot more sense.
Brilliant. And I want to go deep into RLHF and alignment and what potential limitations such an alignment might have to the capability of a model. But let's go straight into the philosophy. So I want to talk about differential semantics in large language models. So Wittgenstein kind of spoke about grounding meaning in practices, which is very pragmatic, or we could alternatively talk about an ultra-relativistic sense of semantics being observer-relative, subjective, etc. But in most cases, we arrive at the meaning of an utterance being in its use versus the monolithic representation we see in large language models, and we can debate the extent to which we can call them monolithic representations. Maybe we shouldn't, but they seem to have semantics. And we can discuss whether they do or don't have semantics. But maybe we're hitting the ceiling of what's possible. Now, I wanted to sketch out an example. Now, let's use the concept of evil. I think this is quite a cool semantic thing to play with. So people on the left, actually, if you look at psychologist diagnostic criteria, the concept evil does not exist. And if you ask someone like Jocko Willink, on the other hand, he'll tell you stories of how when he was on tour in Iraq, he saw people, he viscerally felt that they were evil people. So people who believe in the concept tend to be consequentialists rather than more moral realists. They tend to eschew agency and individual responsibility. They tend to lean to the right of the political spectrum. People on the left rely on a more pragmatic context. I mean, you can see where we're going with this. So how could a monolithic large language model possibly wrestle with differential semantics like this?
Jesus Christ. I feel like I'm in a philosophy exam from a decade ago. My gosh, there's so much to unpack there. I mean, so your question is, how can a model that just modeling the surface statistics of language capture something about the semantics of a notion like evil? It's a very difficult question to answer, because to approach it in a sort of proper manner, we first have to, in a sense, answer the sub-question of what are the semantics of evil for us as humans, right? And as you point out, there, like any issue that is of a philosophical nature, there are completely opposing views within the philosophical community, let alone within the lay community, and it's very difficult to determine which ones are right because we can't really touch evil in the same way that we can touch a table. I'm personally of the idea that like these expressions are linguistic fictions. I mean, they're pointing at something and how we as a society operate rather than as being moral truths or falsehoods. But I accept that there are people who are perhaps more on the sort of spiritual or religious end of the spectrum that may be moral realist and say, look, the semantics of such expression is grounded in the same way that statements about tables and phones on tables are. It just happens to be that these facts are not of a physical form. The objects are not of a physical form. So in a sense, that question is not going to be something we're going to resolve here at this table today. So what's the best next answer? The best next answer, I think, is to say, well, look at what large language models are doing. They're just capturing language as we use it, right? They're capturing language as moral realists use it. They're capturing language as moral subjectivists and as... I'll have to forgive 10 years since I've taken something resembling an ethics course, but can't remember how we would characterize the opposing position. But we capture the ways in which people would use moral utterances across the spectrum. So to turn the question on its head, are language models doing anything different than how other humans are capturing these semantics? Right? They're using it in a way that's potentially in the limit indistinguishable. The main sort of like core difference is like, is there any intent, soul, or something behind the words that is relating to the fact? And perhaps that's the nature of your question. I've sort of lost myself in my train of thought there.
Well, no, and yeah. So I would like to explore that in a minute, which is this idea of, is there more behind the words? Syntax versus semantics.
Right.
Bring in Nagel and all that kind of stuff. But let's talk about Peirce's triad quickly. I'm kind of skipping ahead, but it was iconic, indexical, and symbolic. So a good way of thinking about it is, according to Chris Summerfield's book that I just read, is the iconic is kind of a physical similarity, and the indexical you can think of as a kind of spatial temporal relationship, and then there's this this symbolic, which is for very abstract concepts that aren't grounded in the everyday world. And so he said that language might be the substrate where we embed and learn symbolic concepts, presumably through the same mechanism we use for indexical concepts, which is to say spatial temporal contiguity. So for example, Christmas reverberates because there are presents and nativity, and if you see Donald Duck next to the Eiffel Tower, you can potentially learn concepts using this spatial temporal contiguity. And he said clip embeddings are a great example. They respond to concepts like Christmas. You see the lights, the Christmas trees, and so on. So the question is, have we already solved this conceptual abstraction problem or not? The big question is whether these large language models just represent the convex hull of our experiences, or could they learn new concepts?
I think that's a good question. So, I mean, they definitely seem to reuse concepts that we use as humans because we are able to converse with ChatGPT, or able to converse with a Cohere's command model to plug our own medicine and our internal conversational efforts. And
just get the mic a bit closer.
At points, you can sort of lose track of the fact that you're talking to an artificial agent because you're actually getting something useful out of the conversation, and it progresses naturally under this illusion that you're talking to another human being. So we are at a stage where this technology can sufficiently fool us into, and I'm using that with scare quotes, which I should have done in person, fool us, that we're talking to another human being at least for some period. So to that extent, it seems like they capture something about our human concepts and that they achieve this sort of point. But I think the true test of whether or not an artificial agent is able to express novel concepts, can they communicate novel concepts to us in a way that surprises us and can actually demonstrate that those concepts have pragmatic value, right? I'm asking myself out loud during this interview, has that happened in anything I've experienced? Like, I have had delightful and surprising interactions with large-scale language models, including ChatGPT, that have been useful in helping me understand what sort of programming framework I should use to design a front end for a pet project, or how I should resolve a personal problem. But I wouldn't say that any of these have introduced completely novel concepts that are of a scientific or philosophical nature, but perhaps I just haven't had the right conversations. So that would be a nice sort of like very difficult to turn into a falsifiable hypothesis, but a nice litmus test, soft litmus test. Can large-scale language models or can artificial agents conceptually surprise us? Like introduce something where we actually have to grok it rather than just appreciate that this could have been said by a human.
Okay. And so talking a little bit more to this semantic and pragmatic divergence, and by the way, I of course, spoke with Laura Ruis, and there's the pragmatic, the implicatures paper, which we can bring in. But there's quite an interesting thing here. So an example from Luciano Floridi is that the music of the radio is what we perceive. It's our ontology. The radio is irrelevant. The ontology is the music. So there's this epistemology versus ontology, the subjective versus the objective. Douglas Hofstadter went one step further in his book, The Strange Loop. He had this example of a record player. So there's the physical needle going over the bumps on the record, and then the electrons going to the amplifier, and the speakers moving the sound waves, and it goes into your eardrum, and the music that you experience, it emerges in your mind. And the next day you can play the same record, and even though the physical substrate is very different, it's different air particles and so on, the same music emerges in your mind. So he would say that the provenance matters, right? He would So he would say it's not just the technique of the musician or the aesthetics. You know, there's the subjective experience, the purpose, the provenance, the pragmatic context. All of these things contribute to your experience of the music.
Maybe this doesn't address exactly what you were saying, but this brought to mind an interesting thought. Is like you can sort of see listening to a record player as listening directly to the orchestra. It just happens that there's some asynchronicity to how that was relayed to you. And the same sort of metaphor could be used for seeing how we talk to a large language model and perhaps to other humans. I mean, when you're talking to a large language model, you're in some sense talking to sort of the collective data that it's been trained over, right? There's really nothing else. It's just, there's nothing magical at the beginning of the training of the large-scale neural network, just random initialization. So all that you're talking to is the distillation of the information that was contained in the large language model. Obviously, this metaphor breaks down a little bit when you include models that have retrieval in the loop, the ability to interact with the environment and obviously encompass that context in their responses. But I think there's something quite poetic there, because the same thing could be said about what we're doing when we're talking to other humans. I mean, if you're, a free will denier, then talking to other humans is, sure, you're talking to something that, as a linguistic construct, we talk about as being an independent agent with its desires and whatnot. But really, you're talking to the byproduct of its evolutionary and social history, to the collective sort of like humanity that brought that agent to that point in that moment where you're talking to it. And deep down, it feels like these things are differing only in some sense of scale. Or at least you can if you buy all these assumptions that we don't have free will, that there is no sort of like spark of the soul, or light of consciousness seems to be the hip sort of like a word these days that makes us in some sort of like non-physically reducible way substantially different from an artificial agent.
Interesting. I mean, a lot of this seems to come down to subjectivity in itself. And I think what you're pointing to there is, could there be an objective phenomenology, and what exactly happens when, because a lot of this stuff is embedded in our language. It's emerged over a long period of time. We embed it in this large language model, and the reach is surprising. But would you fundamentally push back against this notion that semantic content, is very subjective?
I think, just to harken, you mentioned Wittgenstein in passing. I'm very close to sort of the later Wittgensteinian view that semantics is primarily about pragmatics. Language is not pointing to some abstract sort of things in the world, or isn't an imperfect vehicle for the perfect language of the mind, as Leibniz would have had it. But it's just a tool. It's just a way in which we obviously communicate, but also we get stuff done. We resolve conflicts, we transact, and it's very difficult to disentangle semantics from the context and use of the vehicle for those semantics. So I'm very much on the sort of camp that if we're talking about the semantics that large language models have, it must exist because we have practical use for them, right?
So I would agree with that. I mean, I'm amenable to the Wittgensteinian view that, as you say, it's embedded in the pragmatic context, in the language game and so on. And that was a riposte in many ways to this impenetrable realm of the subjective experience, or this kind of, mind-body dualism. But that doesn't really seem to have much friction with large language models.
In what way?
Well, in the sense that large language model, it's a materialized snapshot of this language game, but it itself is not a language game.
That's true. I mean, so that's precisely what my student Laura's agenda is teasing at. I mean, you've interviewed her and discussed her wonderful paper on trying to measure whether or not large language models possess any sort of understanding of pragmatics, and therefore under our view, semantics as well. And to remind your listeners of what the conclusions were, is there was a bit of a dividing line between models that were just trained to model the probability of the next token on general sort of corpora of text, and ones which had been trained to follow instructions, which seemed to capture at least superficial pragmatics in the form of like resolving binary implicature. So that seems to indicate the possibility that there's nothing fundamentally preventing neural architectures from starting to align with pragmatics in some shallow way. Mm-hmm. The question is, how far can we tease that? How far can just training on supervised data bring us? And that's, I guess, one of the key open questions is how to explain Laura's result. Is it because these models are trained with RLHF? At the time we thought so, and then during the publication cycle, OpenAI announced that DaVinci 2 was just off supervised instruction data. Was it because there was a lot of code as a modality in the training data? And again, the question is, why would that matter? There was a very interesting blog post by Yoav Goldberg recently where he hypothesized that, you're nodding, so you read it, which I thought, Yoav has always been a very thought-provoking and a highly intelligent person, so I always love reading anything he writes. And I thought that was quite an interesting point he made, which I'm going to try and remember exactly. I had understood the contribution of code in the pre-training of, sorry, maybe to walk this back, there's evidence that including code in the training of large-scale language models helps them not only be better sort of modelers of code, but also of natural language. And it's interesting to think why that might be. And so sort of my hypothesis, I think, until I read Yoav's blog post, was that having to model code is to model sort of significantly more regular structure with significantly more local and long-range dependencies than in natural language. So natural language, we have co-reference, sentences follow the general context, but in code it's very unforgiving and very precise. If you change the order of two sentences, if you a variable always references to the current sort of version the current state of the object, or if it's a constant back to when it was defined. You need to capture all these sort of intricate interdependencies in order to be able to properly model just the syntactic level of code. But Yoav makes this point that maybe there's something more here. Maybe it's that code as a language is like immediately amenable to grounding, that the syntax is a very strong indicator for the semantics, and that you can just run it, right? If you like, you can just run the code and actually see what the semantics was, which I think is what he says. Reflecting upon it, that's not necessarily always true of the code I write, where it crashes in completely novel ways. But yeah, and I think there's something there. It's like that there's these other modalities that are formal languages, but that have a perhaps different form of pragmatics and semantics than natural language, but that are not completely disjoint, and that models can, by capturing the surface form, are actually good at that transfer something over to our understanding of natural language. How else can we explain this surprising result?
Interesting. Do you agree with Montague that our language is a formal language?
Well, I spent a large part of my PhD working on some sort of extension of Montaguevian semantics. So, I mean, I think I started from the idea that that sounds good, but so I don't expect you to have read my doctoral work. But the long story short of my doctoral research was extending Montaguevian semantics, which your listeners, if they're not familiar with, is the idea that you can take the syntactic structure of a sentence and assign to types and tokens particular sort of like partial elements of a logic in the lambda beta calculus, and then by following the syntactic structure reduced to a logical expression, which I found was a beautiful idea and very early Wittgenstein in a certain way. And my introduction to philosophy was reading the Tractatus and not understanding it, and then rereading it 10 years later and not understanding it. So I liked toying with that, but I started my doctoral research at a point where Bob Coecke in Oxford and colleagues wanted to sort of unify this Montaguean view with a distributional view, with a view that, like, okay, it makes sense to follow the structure of language, but not so much to be committed to the fact that the underlying semantics is a logical expression. And so they wanted to build a compositional, distributional picture of language that, inspired by Montague, would use the syntactic structure to decide how to combine vectors in order to produce vectors of larger units of text. And this was all powered, like as physicists love to do, by overly complex mathematics. We used a categorical framework, a category theoretic framework that was used for modeling quantum information flow, and thought, hey, let's just solve language with it.
Yeah, I interviewed Bob Coecke.
Yes.
And did the Lambert calculus and the tensor outer products and all that stuff.
And so he was my supervisor, and
it's a small world, isn't it?
It is a small world. The quantum and LP stuff that we're still working on, which is a fantastic and really interesting sort of line of work. But yes, I was kickstarted right before the beginning of my DPhil with him and Manu Satterzadeh and Stephen Clark, who now works at the same company as Bob, I don't want to go too deep into my personal history, but I was just finishing a master's in computer science, having never done computer science before. Just was not tired of philosophy, but I didn't think I could make it as an academic philosopher. And they were like, well, we need someone who understands physics and, tensors, and also is interested in language and programming. And I was like, I'll work on that.
Amazing.
So that was my sort of departure from the Montaguean view, but in a way that was trying to extend it, right? Saying let's say that syntax directs semantics, but the underlying formalism is a more ambiguous and messy world of vectors.
Yes, indeed. And folks should definitely check out that interview we did with Bob Coecke. But yeah, this idea of being able to embed the semantic space in different envelopes, if you like, not necessarily just a vector space, but. So you were talking about, in general, various different command models and the effect that command models and things like preference models, RLHF, etc., they have a big effect on these language models, and they make them more aligned to us. And I was watching a podcast by Robert Miles the other day, and he had this slightly esoteric view that, in a way, alignment makes them dumber, or if not dumber, it polarizes them. It makes them simultaneously smarter and dumber at the same time. So if you prompt it in the wrong way, it might introduce security vulnerabilities, but if you prompt it in the right way, it might be smarter. And he had this idea of the model almost being like a simulator and a simulacrum, like the real intelligence of the model is kind of hidden behind this new anthropomorphic interface that we've kind of created in a weird way. So why don't we just kind of like zoom out a little bit, just introduce RLHF and what do you think is going on there?
Well, that's an interesting line of questioning. So precisely because I'm despite the fact I work a lot of reinforcement learning, I've worked in reinforcement learning at Meta, and obviously with my group UCL Dark at UCL with Tim Rockdash, we have a number of projects on reinforcement learning and open-ended learning. I'm actually quite skeptical about what the benefits of RLHF might be, or to put it more generously, whether people rush to use this sort of class of techniques too early, right? And so, I mean, without going into sort of the delicate technicalities, because I don't think it's even necessary, RLHF is primarily about trying to distill what human judgments might be like if you had a human in the loop, in order to determine whether or not, for example, one of two completions that your model could offer are preferable according to human preferences. And obviously, if you had a human in the loop, that would be a significantly better thing to do. But if you have enough evidence of how humans would complete an instruction, or prefer or rank different ways of completing an instruction, you can have something that generalizes faster, generalizes sufficiently that it can be a sufficient proxy for the human. And I think there's a lot to like about this idea. I like the sort of level of indirection that it has over directly, modeling completions produced by humans, by human experts. And it reminds me a lot about approaches like generative adversarial learning, for example, which was trying to extend generative adversarial imitation learning, GALE, by Ho and Ehrman, that extends imitation learning by saying, well, okay, instead of just trying to directly imitate the reference policies that you have by modeling their statistics and then, seeing that things break in reality because you're doing well when you're in the same part of the state space as the expert policy. And if stochasticity or modeling error takes you out of that, then it's suddenly very brittle. So they said, well, it's under the intuition that's easier to teach someone, that's easier to be a recognizer of good cooking than to be a good chef. Let's add a level of interaction where a reward model is abduced from these policies through a GAN-inspired framework that allows your actual policy that's learning to have an approximate reward from the reward model that tracks or aligns with what the expert would have done, but is in some sense free to diverge, right? And it's free to diverge because there's a source of additional information that isn't in the reference trajectories, that is, in fact, the errors that are made by the agent operating on the environment. And this class of methods is significantly more robust. So I see RLHF as being a spiritual successor to this kind of line of thinking within preference-based approaches to modeling. Why I'm skeptical is because it's still like RL is a beautiful sort of class of methods. It's still quite noisy, and there's a lot of ways to get it wrong and right. And the cost of iterating and experimenting with that often reaches a point where you have to ask yourself, is it not just cheaper and more direct to get extremely stable signal by getting annotations directly from annotators? So that's closer to what our current strategy is. And I think what a lot of people should do is see how far we can get by just doing good quality control over the data we get from annotators and exploring cheaper annotation mechanisms. I mentioned earlier the anthropics or preference-based, taking something akin to the log ratio of likelihoods. Seems to me to be a significantly more stable signal and also significantly more scalable. So my advice to anyone is see how far you get with data and the ways in which you can get more data before you turn to RLHF. I was talking to someone whose name I forget at NeurIPS from Carper or Carper AI. Carpenter.
Oh yeah, aren't they related to Aloytha?
Yes, yeah.
I might know them if you...
I can't remember his name. I'm very sorry if you're listening. But he gave me a very nice example of when RLHF might make a lot more sense. That's stuck with me. And,
was it Aaron?
I can't remember. It was for coffee at 7 a.m. the morning after I landed, so I was not exactly in the most sort of like memory and enhanced. I want to say David or Lewis or something like that, but and the example he gave me is that the RLHF makes a lot of sense when you have domains where there's an asymmetry between the cost of collecting a prompt and the cost of collecting a completion. And so the example he had was Socratic teaching, right? It's like, it's extremely expensive to hire experts who can, through Socratic dialogue, teach an agent a particular topic. So you can collect a bunch of prompts like, give me, act like a Socratic teacher and teach me about, how to resolve this ethical dilemma or how to, sort of think about the concept of self, right? It's always cheap to ask questions. Collecting a lot of examples or ranked preferences of what good collecting examples in the first place to bootstrap or ranked preference examples from several experts would cost a lot of money and expert time. And there it makes sense to say, okay, well, no matter how noisy the RLHF model is going to be, it might just be justified by the extreme cost of collecting data. Whether or not that argument on its own makes the case for RLHF, even if it does, the stage in development of large-scale language models where solving Socratic dialogues is the boundary. I don't think we're quite there yet. Again, I haven't tried to have a Socratic dialogue with ChatGPT. Maybe I should.
So I agree with you that humans are much better at discriminating than generating, not only for consuming a large language model, but also for doing the preference tuning. But there are a couple of things that kind of horrify me about the preference tuning. You probably know Yannick. He's building this open assistant thing at the moment, and he just made a video about it, asking people to come and tune it. And it horrified me. It had all of these, arbitrary bits of metadata in there, and this is good, that's not good. And the problem with some of these language models at the moment is if you ask them to generate a poem or something like that, they kind of all look the same. Again, there's something that Robert Miles said, and it's almost as if they don't have much technical knowledge of poems, and you can't help but get the thought in your mind that maybe the model does know about poems, but we've dumbed it down doing RLHF, because the people doing the tuning, they don't know the nuances of how to write poems.
Yes. So, I mean, well, this is just garbage in, garbage out, theory of machine learning. So if you don't have, there's no aligning with humans isn't the be all and end all, because humans are contextually differently expert or able to give you good feedback. And so obviously, if you are trying to use RLHF as a one size fits all without thinking about the qualification of your annotators, you're going to have issues. And you were making another part of that point, which I think also pertains to preference-based annotations, even if you're doing it in a supervised sense. So if you're just annotating Anthropic style, to try and maximize something like the log ratio of probabilities of the preferred path that your annotators gave you, that works only as well as the proposals given by the model are consistent but diverse, right? Mm-hmm. If they're both bad, you don't get any information. If they're both perfect, that's better than nothing, and that you validate that you should probably fine tune on it. But the ideal case is where they're both good and you are differentiated. Your preference is either picking the one that's significantly better in an absolute sense, or in the context of the particular ability you're looking for. And I think that's a pretty powerful paradigm, because it puts all the complexity behind the data collection mechanism in the hands of the annotation designer rather than of the annotator, which is the way it should be.
Fantastic. So I wanted to talk about the Swiss cheese problem. This is, again, something that Chris Summerfield brought up, and he said that the problem with deep learning in general is it's a bit like Swiss cheese. So sometimes you're in a hole, sometimes you're in the cheese, and you don't know when you're in the hole. A little bit like when the DeepMind model, I think against Lee Sedol, it suddenly started, they didn't use the term hallucinating, they actually used the term delusion, which I thought was quite interesting. But anyway, it's basically the same thing. It started just doing crazy stuff because you're in an area of the weight space that, wasn't inside the training support or whatever. This is a bit of a problem, right? Because I use language models all the time and they're brilliant. I asked it earlier, define functionalism, define computationalism, contrast them together. Brilliant. But you don't know when you're in the hole.
Well, that's a particular problem with the more convincing and advanced the behavior, the more we suffer from, an epistemic danger that, it's if model obviously misclassifies a 3 as a 5, and then you're like, oh, it's not that good, right? But if it gives you wrong facts that you rely upon, then you're in trouble if you're going to be making life decisions based on those facts. Or answering an exam question based on those facts. So I think that's where it's especially interesting for us to explore methods that are hybridized. So throughout my career, I've been quite interested in generalization and interpretability, and I've worked on various instantiations of the notion of neurosymbolic systems, from neural architectures that simulate push-down automata to work with Richard Evans, where we had to sort of you had neural networks producing Prolog programs that could then actually be run by Prolog interpreter. And so the continuation of that line of thought is these retrieval-augmented models. And so we have Patrick Ruis over there, who you should also interview at some point, who wrote the actual paper, Retrieval-Augmented Generation, which I find inspirational. And what's nice with models that have retrieval in the loop, and obviously there's been work in many labs touching upon this in the last couple of years, is that they provide us sources for their decisions. And they can still degenerate, they can still hallucinate. There's nothing that is incompatible with the model having retrieved something that could support the answer and then hallucinating an answer completely unrelated to it. It's just less likely. But I like the additional step that there's something that can be pointed to as the rationale, standing for the whatever we would want to call a rationale for a neural agent, that humans can at least verify and just look at. There was a great example. So one of our co-founders at Coecke, Nick Frost, put together in a very short amount of time, like he's excellent at doing a demo called Grounded QA, which is on our GitHub, that was just taking one of our large agents, feeding it a bunch of examples of how to search the web to answer a question, and then seeing that it extrapolated sufficiently robustly to new questions to form queries and produce answers. And obviously produces the rationale, like the top ranking web link that supports the answer. And when he was demoing this in a little video, he was like trying to show warts and all, like, look, here's where I'll ask it a question that's blatantly like not answerable, and we'll see that it hallucinates a fact. So he says, who's the king of the United States? And it answers Barack Obama, and everyone has a little chuckle and all that. And I pointed to him after the video, like, if you click on the link that it gave, obviously the answer, unless you're really a big Barack Obama fan, which I am, but like I wouldn't call him a king. If you look at the article itself, it actually is talking about like, how people have sort of like had these sort of projections of majesty onto Barack Obama, and whether that was, a good or a bad thing is up to the reader. But like how people like are looking for figureheads akin to what the UK has, and that when we have very charismatic figures, that we go more than just see them as charismatic politicians, or capable politicians, but also as like people who have some sort of regal aspect, and we care about their family, and we care. And so the article actually justified the answer. Even if you disagreed with the answer, you could introspect that. So I think that's something I'd like to see more of, like ways in which models can not just search the web, but index into information that increasingly makes them robust and increasingly justifies them, such that at very least when they make mistakes, we have an epistemic basis for saying that was a mistake, and to err as human.
Yeah, I completely agree. I'm very excited about retrieval-augmented, kind of hybrid modalities. I'll have a chat with Patrick actually afterwards. But I have noticed as well that the models are far less likely to bullshit if the information is in the context. So, in that retrieval-augmented setting, go and get stuff from Google, go and get stuff from this operational system, and maybe even do it in some kind of a graph. I think that's very, very interesting indeed. Let's go on to intelligence. So I wanted to talk about intelligence and what makes humans special. Does a submarine swim in the same way a fish does? Does a plane fly in the same way a bird does? In computer science, we've kind of converged on this Turing machine functionalism, which is basically the idea like we think of intelligence in terms of behavior, like the ability to play chess, which is substrate independent. It can run on any physical system. It could be argued that GPT does many of the things that humans do, in the sense that it performs the same functions, therefore it could be intelligent. But it seems quite reductionist to me. Now, Kant said that humans have autonomy. We choose our own actions. We were just talking about Nagel, this impenetrative realm of the subjective experience that can't be reduced or understood or conceived of by other or even other humans maybe, but non-humans. So it's almost like the question of intelligence is barking up the wrong tree. Maybe the real question is human experience. So do you subscribe to the idea that humans are special and that, our minds can't be replicated in silico? And what do you think about agency and intentionality?
So a good timing to ask this question. We sat down with several of my students and my co-lead of UCL Dark, Tim Rockdashel, on Monday morning for a whole half hour, and thought, okay, let's just nail down the concept of agency to sort of like do follow-on work to Laura's paper. And obviously the starting point was like, okay, we're not going to nail down the concept of agency in half an hour, given there's thousands of years of philosophical discourse on the concept. So, I mean, broadly, and please don't quiz me on my actual specific knowledge of Dennett, but my general assumption is I'm a physicalist. I don't believe that there's something like a soul that makes us different from other matter, let alone other animals. I'm pretty skeptical about consciousness. I think it's a linguistic construct, and that if consciousness is something real that we point to with our words, it's on the same spectrum as me deforming this can by squishing it. And I said that in interview with Derek Parfit once, and he said that I was an idiot. He didn't say that in so many words, but he treated me like one. I still believe it. So, like, in a sense, I don't think there's anything special about humans. It's a matter of scale. Like, we're intelligent in the same sense. Like, we're on some point of the scale where, a whole nation is and a can is at the other end, right? It doesn't seem... I know this was... No, who came up with this argument? There was the Chinese nation extension of the Chinese room argument. I remember reading about it in passing or sometime in 2006, like talking about how you can talk about a collective set of individuals as forming collective intelligence. And it was it was a gotcha argument saying, well, like, you wouldn't say that like all of China with their cell phones somehow communicating in bits that turn out to like be running an algorithm. You would say that that's intelligent. I'm like, why not? Why, like, what is wrong with saying that intelligence exists on such a spectrum, and that we are at this interesting point in the spectrum where we're sufficiently located in a clump of cells that we can talk about each other's with other constructs like person, agent, talk about personal responsibility, when in fact these things don't exist in nature. Like, it's like you're in some abstract sense, you're no more responsible for, a murder. This sounds like outrageous as I'm saying it out loud, but no more responsible for a murder than, the bullet leaving a gun is responsible for a murder. But we obviously need to have a differentiation conceptually in our legal framework and in our moral frameworks, because the bullet can't stop itself from killing the person or not if it misses, right? Whereas there is some sense in which we are complex and somewhat predictable agents, and if someone's murdered before, it's more likely than they're going to be, inclined to do that again. And so we come up with this whole framework to talk about agency, to talk about moral responsibility. But ultimately, these are just ways of talking about just complex dynamic systems that are, in our case, sufficiently co-located that we can talk about individual responsibility. Right?
But we could do a reductio ad absurdum as Hilary Putnam did, and I could just take that entire episode of you answering that question and I could decompose it into dominoes or, like little ping pong balls tied with string to cups or something like that, and I could reproduce it in an open physical system. And
those would be some really, really, I'm sure, charming and smart ping pongs and dominoes and cups.
But but when you do that reductio ad absurdum, and you at that point you cut off all the counterfactuals, don't you? All of the trajectories that you could have taken, they don't exist anymore because I've just taken the episode and I've reproduced it in an open physical system. So you wouldn't say that thing had intentionality, would you?
What, like, if we're talking about, we have a physical system that has all those components that just so happen to make the same noises I'm making right now. No, but I don't think I would describe intention. I mean, like, this entire episode could have been, someone else. I guess they would have the intentionality, but it could have been someone else randomly selecting words that happen to align like this. There's a non-zero probability, and then putting on a really good speech synthesis module, right? Mm-hmm. Like, we don't judge intentionality. And judging intentionality is something that is... It's like it's an open question. You can hypothesize that someone's intentional given the evidence, but we look for further evidence that the system will be intentional. And with humans, we're not constantly questioning this because it would be extremely cognitively taxing, and because we pretty sure that we see someone that looks like us, that they're probably going to share some degree of our mores and intentionality and ways of doing things. So as a cognitive shortcut, we rely on the bedrock that is like, okay, well, humans are probably all intentional, right? But that is just a cognitive shortcut, right? Like that's how I go about answering that question. I'd say if there was evidence to the contrary that system wasn't intentional, then all that demonstrates is there was a really good signal in favor of intentionality, and then that further evidence disrupted it.
Yeah, I mean, it's all about what's in the system and what's out the system, and Floridi and Searle would say that agency and intentionality are outside of the system. So when you take the representational snapshot, you lose the intentionality and the agency. But when we talk about agency and free will and creativity, they're three interesting things to club together, because, like, is a language model creative? Like, what does it mean to be creative?
If you produce if you produce something that's not been done before, I guess. But yeah, like, what does it mean for humans? When we think about what makes human creative, what makes humans creative? I mean, I guess it's producing something novel. And so what does that mean? There's obviously there too a spectrum. Is like someone can be just creative in terms of how they arrange their desk or how they, explain a particular concept. And that's a little novel and we take delight locally. And then artists are probably trying to piece things together in a higher order conceptual space. Like, come up with cubism when no one had really tried painting or dotting things like that or drawing things with lines. Really, hopefully not showing my ignorance about art too much here. If cubism is the one where, pointillism was with all the little dots, and cubism is Picasso? Okay, well, I'm not going to win any art prizes for this interview, but you know what I mean, right? So they're combining concepts in a more abstract space and then bringing that back down into some form of like expression, images, text, like theater. But the overarching definition still remains. They're just putting something new out there. Just at what latent level of conceptual complexity are they operating? And so right now, large language models are creative in the sense of like someone who can put together new sentences, right? But the question, to turn the question on its head, is that in any way that different from how someone puts together a play, other than on the scale and magnitude of the abstraction being manipulated?
Yeah, it's interesting. I mean, we can both agree that free will is not a random number generator. There's some kind of a direction and some notion of what's interesting, some notion of a prior, some notion of a manifold, of an abstract concept space that we can traverse. So there's a lot of structure there. There's some kind of a cone of attention, but you're kind of saying that within that structure, it's basically just a random trajectory.
Well, I don't really buy free will. So not like you're right that there's stochasticity in the environment, and perhaps fundamentally in physics, and that explains the difficulty of predicting things. We're not deterministic systems in that sense, but I don't think there's anything fundamentally different happening than other dynamic systems evolving due to inputs and then producing outputs.
I mean, one reason why large language models might seem so crazy to us is the lack of common sense. So they're just in the language modality, and of course, when we have agents, they have affordances, they have actions, and so on. So you could argue that with this basic statistical paradigm, we just don't have the right setup yet, and actually some of this stuff will be learnable. But I wanted to talk about, you probably heard of Moravec's paradox. He wrote in 1988 that it's comparatively easy to make computers exhibit adult-level performance on intelligence tests or playing checkers, and difficult or impossible to give them skills of a one-year-old when it comes to perception and mobility. And Minsky said that we're more aware of simple processes that don't work well rather than complex ones that work flawlessly. Easy problems are hard, basically, like Melanie Mitchell wrote about in her paper. And Christopher Summerfield said in his book that we admire Lee Sedol for his prowess at Go, not for remembering to get dressed beforehand. So, common sense is kind of taken for granted. But why don't AI systems have this common sense yet?
It's a good question. So I'm not an expert on common sense. I have a lot of respect for work of Yejin Choi, who's worked on this in NLP, and there's a number of other researchers who've looked into this. So I'm going to speak from the standpoint of someone who's an outsider to that study of that aspect of language. So for ages, I just saw the common sense debate about being the fact that, in the context of language modeling, I saw the lack of common sense being more related to the fact that there are facts that we obviously grasp as humans that are not necessarily going to be reflected in the sort of documents that we learn our language models from. So a great example of this is if you have a bunch of news text, you're more likely to see things about man bites dog than dog bites man. You're not going to see sentences like grass and green because they're precisely because they're common sense, because they're obvious. It makes these things so obvious that we just don't feel like it's necessary to state them in a form of text that seeks to exhibit novelty and convey information. Is simply that information comes from a different sort of source. It comes from the fact that we observe grass, that we talk about like colors, and we exemplify sort of base objects, that we understand the nature of like dogs as being sort of semi-controlled, tame animals that occasionally bite people. And so we express no surprise at seeing these facts in text. So therefore, they're less frequently attested. And as a result, models that are trained on that modality are less likely to capture these sort of things. If you extend that line of thinking, there's a lot of other ways in which we understand the world that are expressible through language, but that we don't primarily experience through language, like walking around, like we don't spend our day talking. We talk non-verbally as well. We perform actions. We see other people performing actions. We have a whole sort of non-linguistic aspect to how we reason about things, visually, emotionally, that is not going to be constantly conveyed through the medium of natural language, but rather, expressed through it. And so I think a lot of observing ourselves interact with the world in such a way and perceive the world in such a way and interact with other agents who we will assume are doing the same sort of thing is how we acquire a larger amount of knowledge that we qualify as common sense that isn't readily expressed or necessarily going to be expressed linguistically. It just can be, right?
Interesting. Although on the flip side, I mean, Jan LeCun put a tweet out saying, we need to have cat-level, dog-level AI first. And I think Ethan Caballero responded saying, turned out it's easier to get human-level AI because it's kind of embedded in
Well, yeah, as per your earlier point, and I had not heard that paradox, and I forgot the gentleman's name.
Moravec.
Moravec. I'm assuming his gender is a
it's a guy, yeah. That's a very astute observation. So, I mean, I think a lot of that comes from the fact that a lot of these higher cognitive games and activities are very constrained ways or almost toy ways of operating on the world. I mean, that sounds like I'm really reducing the sort of intellectual difficulty of chess, but chess is a very constrained sort of like world, right? It's just incredibly complex, and so therefore playing it at a high level is cognitively demanding, but it's demanding because we have to focus all our intention and all our intelligence into like planning and understanding the dynamics of this complex but constrained world. So perhaps it's no surprise that for the same reason that calculators are better at doing 8-digit multiplication than an average person without preparation, that computers are actually capable of like tracking human performance under such constraints, and that what makes it so much more difficult to do cat or dog or child level intelligence is that these are systems that are able to deal with and conditioned through evolution, conditioned through society and through biology, to deal with a changing world and to adapt for survival. And humans are perhaps the greatest example of this. I've always been, again, I should specify, I have absolutely no education in beyond high school level in evolution and in anything really to do with biology. But it always surprises me how so many animals come out of their mothers able to walk, right? And it takes kids like over a year, and it's like a baby horse is like walking within minutes or something. And so I was thinking about this, like, is there some connection there between the sort of generality and adaptability that humans exhibit and the fact that it takes us longer to learn these base sort of cognitive mechanisms? So, it's like the horse, if it doesn't run pretty fast, obviously is going to have a bad time if there's a predator. And so evolution has pushed it towards having this rapid skill acquisition on that axis, or having it really be innate at the cost of being able to sort of like learn how to interact with the world. And that's what babies are doing, right? They are very good learning to adapt to machines, I think, and modeling that sort of like higher order mechanism of dealing with information and of dealing with the information gathering process is a more complex thing than just learning to search through a decision tree over chess moves, right? So I buy that there's something fundamentally more complex, and that addressing that problem will be part of what brings us towards human level intelligence. So is it necessarily the only path? I don't really want to commit to that, but I can see the merit behind Jan's argument that learning from systems that are more general and more robust is a sensible way to go about it. And I would very much like research in that sort of direction to continue. Cool. Okay. Thinking versus knowing. So you've got 5 minutes, right?
Yeah.
Yeah. Okay. Fileshun said in 1973 that cognitive psychology is concerned with two types of questions: what we know and how do we acquire and use this knowledge, which again Summerfield distilled down roughly to how we know things and how we think. And it's been a kind of core dividing line of AI research since the very beginning. And roughly speaking, the Dartmoor group at the very beginning, they were concerned with thinking, and the kind of Rosenblatt school of thought, which now leads to modern neural networks. You can think of neural networks as being a way to partition and represent knowledge primarily. And even in humans, when you have your prefrontal cortex kind of like severed later in life due to stroke or damage or whatever, these people outwardly still seem very intelligent. Like they can score high in IQ tests. They don't do many novel things, but they're still outwardly quite intelligent. So there's this kind of pendulum between knowing and thinking. And coming into thinking as an example, one of the best arguments for thinking, I think, is compositionality. That's something that might be missing from neural networks. So these symbolic approaches allowed for limitless productivity from mental primitives. Complex concepts can be composed from simpler building blocks using sets of formal rules. So giving us versatility, flexibility, expressiveness, and so on. Obviously, we can get into Chomsky's innate mental grammar. But do you see what I mean? That there are some kind of like lines of thinking which are not really in the current paradigm.
So I think I agree with the point that neural networks are sort of like and we're talking just a large language model without any extra bells and whistles. And this applies to another even larger class of neural networks and application domains are distilling the information from the training data. And as a user, you're hoping, perhaps praying, that through the magic of amortization, that it will somewhat extrapolate to data points that are like the training data, and that you'll be able to do something useful with it. So that's very much on the sort of like knowing and then sort of educated guessing kind of end of the spectrum. And so if you see thinking rather as a process of putting together new knowledge given interaction with the environment, or logical atoms, or building blocks of concepts or whatever, that seems to be a more cognitively demanding process, but that speaks at a higher degree of generality because you're able to sort of analytically or synthetically derive new knowledge from existing knowledge and from new facts, right? So that's a lot more appealing. Which brings me back again to plugging this idea of hybridization, right? Which is, if you look at what models that are capable of not strictly large language models, but large language models, for example, that can interact with search engines, that can have some sense of a memory, that can perhaps determine how to update part of their weights, or reinforcement learning agents that can perform rapid adaptation in the environment. Those start to exhibit some aspects of both, being the distillate of their experience, of their training experience, and also being able to, exhibit some aspect of this thinking of being able to compose building blocks in order to adapt to new circumstances. And where these things sort of start to be a little bit muddled is there's a lot of recent literature on this in-context learning. So if we have a sufficiently large language model, are they in fact doing something like in-context learning all the time? Because they're traversing the data for the first time, perhaps only once, if you're training them a significantly large amount of data. So are we actually thinking about it under the right paradigm by saying that they're just distilling information rather than to explain the training data under that sort of pressure? They have to learn how to sort of say, I can see sorts of patterns in my recent history that I can condition on, and they give me a sufficiently good signal about like how I'm going to be doing, the rest of my task, rather than just conditioning on its context, right? Which is how we naively would see a language model. We'd say, okay, if it's a long receptive field for a transformer, it's capable of capturing really long co-reference resolution. But what if it was doing something more, right? If it was using that capacity to actually learn to sort of like adapt to data distribution constantly, and there's no longer a clear sort of distinction between those two ways of thinking. That's not something I thought about very deeply, but it's come across in conversations with one of my other students, with Tim Rockdashel, Minchi Jiang, who has a brilliant set of ideas on this sort of topic. So.
Oh, amazing. I'd love to interview. I've got Tim on my radar as well.
Tim is great. Minchi, to be frank, everyone who at UCL Dark is fantastic. But Minchi Jiang is a great thinker in open-ended learning, so I really recommend interviewing him. Yeah,
I love open-ended learning. I'm going to work my way through, but I'm really interested in context learning, and did an interview with Hattie Jo at NeurIPS on her in context learning paper. And okay, we can agree that language models have emergent reasoning capability. They don't have consciousness, they don't have agency. They do have emergent reasoning capability. And is it only in context, right? So it feels like, what's the cache value if I have to do this chain of thought prompting, this scratch pad and so on? Is it just in the context?
Well, not necessarily. So if you look at, so now the sort of class of models that we see the most utility from, and so people are very impressed by ChatGPT, but really what they're impressed by is that it's an interface that's a lot more intuitive to non-technical users for interacting with an instruction following model. So these models have shifted from just trying to continue a pattern, and for whom we had to produce these almost analogical reasoning sort of prompts in order to get them to do something. You just tell them what to do. And to explain how a model can zero-shot follow an instruction like that, it has to be both referring to sort of the semantics of the instruction as they're presented there and whatever supporting data there is in context, so the in-context part, but also it has to be pulling information from, like, it's amortizing from all the other instructions it's seeing, is trying to piece those together and find something that, some pattern and all that from which it can extrapolate a continuation that makes sense for the current instruction. So it's both adapting to the context that is provided by the prompt, but also pulling in information from its training history, combining perhaps knowledge and reasoning in both in one fell swoop.
Amazing. Well, unfortunately, Ed, we've run out of time, but I don't know if you have any closing statements, but it's been an amazing honor to have you on the show.
No, my pleasure. I mean, my main closing statement, I think this is in a pleasant way, probably the most difficult interview I've had to do. I feel like I've been I feel like I'm at an interview for some sort of like philosophy fellowship without having prepared for it, but that's fantastic. And I really think that this is something we need more of in our field. Is not just this, we're an engineering discipline. We're very results driven, but we need to have more and more people who, while doing that, because it's good to keep close to the metal, think about the broader conceptual problems and interact with communities beyond just, CS, and like talk to philosophers and talk to sociologists and talk to historians, because like this is a fantastic, I think, dawn of a new intellectual discipline that we're at. It seems very navel-gazing and sort of like self-aggrandizing, but we're at a point where we have to also rely upon the distilled experience and the lines of thinking that exist outside of our field. So I'm really pleased to see that there's interviews like this and an interview series where these questions get brought up.
Wonderful. Thank you so much.
My pleasure.
Thank you so much. Pleasure. Can you ask Patrick if he can jump on just to talk about his paper? Because kill two birds with one stone.